Right, 1.1 notes. We're going to talk about the midpoint and distance formula. So starting with our distance formula, I'm going to jump ahead to the third page here. This is our distance formula. So the distance between 2 points, I'll call it point A and B. If point A is x1, y1, and B is x2, y2, we use this formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So this formula you guys have to have memorized for the test. So example 3 says, which of the points P or Q is closer to the point A? So we want to find the distance between P and A, and then find the distance between Q and A and see which one has a shorter distance. One with a shorter distance would be closer. So first let's find the distance between P and A. So I'm going to label my point x1, y1, x2, y2. Again, we're going to plug it into our distance formula. x2 minus x1 squared plus y2 minus y1 squared. So we have 5 minus 1 squared plus y2 minus y1 would be 3 minus negative 2 squared. 5 minus 1 is 4 squared. And 3 minus negative 2. Awesome, this turns into a plus. This would be 5 squared. 4 squared is 16. What's 5 squared? 25. And 16 plus 25? 41. We can't break down 41. So this would be our distance between P and A. Any questions there? Let's do the same thing, but we're going to find the distance between Q and A now. So I'll label Q as my x1, y1, since A is already x2, y2. So we have the square root of y2 minus y1, so 5 minus 8 squared, plus y2 minus y1, 3 minus 9 squared. What's 5 minus 8? Negative 3, perfect. So negative 3 squared plus, what's 3 minus 9? Negative 6 squared. So negative 3 squared would be 9. And what's negative 6 squared? 36. And 9 plus 36? 45. We can break this down, but I'm going to leave it like this for now. Let's answer the question. Which of the points is closer to A? P is closer. Awesome. So P would be closer. Since this is smaller, it's got a shorter distance, P is closer. And then just for extra practice, let's break down the square root of 45. What are 2 factors of 45? 5 and 9. What are 2 factors of 9? 3 and 3. So we circle any pair. What pair do we have? So what comes to the outside? And what stays on the inside? Awesome. So 3 square root 5. So it says find the distance between the following points. Leave your answer in radical form. So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's super helpful. Label the points. So for example 1, I'm going to label my points. The first one's going to be x1, y1. The second point's going to be x2, y2. Then from here, we can just plug it into our formula. So we have the square root of x2, which we said is 1, minus x1, which is negative 6 squared, plus y2, which is negative 1, minus y1, which is 5 squared. So we just plug it into the formula. From here, we just have to do the math. So make sure you follow your order of operations. You want to do what's inside of the parentheses first. What is 1 minus negative 6? What happens to the minus a negative? What does it turn into? A plus. So 1 plus 6 would be 7. Awesome. So we have 7 squared plus, what is negative 1 minus 5? Negative 6 squared. What's 7 squared? 49 plus, what's negative 6 squared? Positive 36. And then we have 49 plus 36, which would be what? 85. Let's break it down. Always, always simplify your radical if it can be simplified. So let's see, what are 2 factors of 85? What's one factor that we know? If it ends in a 5, so we know that 5 goes into it. You can always divide 85 to see what the other factor is. That's 17. Can we break 17 down? No. Do we have any pairs? No. So what's our what would our answer be? Square root 85. So that would be our final answer. So simplify it if you can. If it can't be simplified, then that's your answer. Any questions here? Let's do it again with number 2. So I'm going to start by labeling my points. I have x1, y1, x2, y2. And then I'm going to plug it into my distance formula. So my distance formula I have up here still. x2 minus x1, so that would be 0 minus 10 squared, plus y2 minus y1, so 4 minus 3 squared. What's 0 minus 10? Negative 10 squared, plus what's 4 minus 3? 1 squared. What's negative 10 squared? 100. And what's 1 squared? 1. So this would be the square root of 101.
Does it matter which one you label, like x1 and x2?
It doesn't. Because if I was finding like the distance between this point and this point, it doesn't matter if I start at the top one and go to the other one. So it doesn't matter which one's your first, as long as you're consistent. So if I make like the first one x2, the one that goes with it would have to be y2. Let's see if we can break down square root of 101. Do we have any factors of 101? No. So that would be our answer. All right, lastly, let's do 3. So I've got x1, y1, x2, y2. So we have the square root of x2 minus x1, so 5 minus negative 2 squared, plus y2 minus y1, 7 minus negative 3 squared. So what's 5 minus negative 2? 7, perfect. This turns into a plus. So 5 plus 2 would be 7. So we have 7 squared. What's 7 minus negative 3? 10. Awesome. Again, this turns into a plus. That would be 10 squared. So 7 squared is 49. And 10 squared? 100. 49 plus 100? 149. Can we break down 149? Any factors of 149? Nope. So this would be our answer. Next thing we're going to talk about is the midpoint. So this is another formula that you guys have to know for your test. So our midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. It's the average of the x's and the average of your y's. Your midpoint is going to be a point. It's going to have an x comma y. So your midpoint will be a point. So make sure you know this formula for the test also, the midpoint. So we want to find the midpoint between the following points. I'll write our midpoint formula here for us. We have x1 plus x2 over 2, comma, y1 plus y2 over 2. Now when you're adding, the order doesn't matter. When you're subtracting, the order matters, so be careful. But when you're adding, the order doesn't matter. I could say 2 plus 4, that's the same thing as 4 plus 2. So just keep that in mind. So we have x1, y1, x2, y2, and let's plug it in. So x1 plus x2 would be 17 plus 9 over 2, comma, y1 plus y2 would be 4 plus 3 over 2. What's 17 plus 9? 26, awesome. So 26 over 2, and then what's 4 plus 3? 7 over 2. And then lastly, let's simplify. Can I simplify 26 over 2? What does it simplify to? 13. What about 7 over 2? No. So we'll just leave it as 7 over 2. Yeah. What? That's the answer. Yep. So for your midpoint, your answer is going to be a point. Let's do number 2. So I'm going to label my points x1, y1, x2, y2, and then we'll plug it in. So we have negative 4 plus 5 over 2, and 6 plus negative 1 over 2. What's negative 4 plus 5? So 1 over 2. And what's 6 plus negative 1? Perfect, 5 over 2. Can I simplify either one of these? No, so we can just leave it like this. This would be our answer. So let's say that it gives us the midpoint. That's, we'll say 0, 4. And then it gives us one of the endpoints. That's negative 2, 10. And it says find the other endpoint. So here it gives us the midpoint, and it gives us an endpoint. We have to find the other endpoint. So we kind of have to work backwards a little bit. So our formula, I'll write it here for us, is x1 plus x2 over 2, comma, y1 plus y2 over 2. No, because it's not going to be the same for, like the x's aren't going to be the same distance as the y's. So we're going to use the midpoint formula. So I'm going to find first my endpoint for the x. So just working with the x, I know that my midpoint for just the x is x1 plus x2 over 2. Where my endpoint, I'll call it x1 and y1. And then my midpoint is my midpoint for the x, and then my midpoint for the y. So to find my midpoint for just the x, I'm going to use this part of the formula. So just like the first part of our parentheses. All right. So my midpoint for the x is 0. So I'm going to plug in 0 to what it's equal to. Then my x1 is what? Negative 2. So I have negative 2 plus x2, we don't know yet, over 2. I'm trying to find the other endpoint, which is going to be x2, comma y2. So here we've got a little equation that we just need to solve for x2. What would I do to solve for x2? Awesome. Since it's being divided by 2, we want to do the opposite. We want to multiply both sides by 2. So it cancels there. So it cancels out with the denominator. So we don't even touch the numerator. What's 0 times 2? 0. So we have 0 equals -2 plus x2. What would we do next? Add 2. So we have 2 is equal to x2. So this would be our answer for x2. 2. So that's the x in my endpoint. Any questions on what we just did there? We're going to do the same thing and find our y. So we want to find the midpoint for the y now. So the midpoint for the y is equal to y1 plus y2 over 2. Now let's plug in what we have. What's our midpoint for the y? 4. So 4 is equal to, so our midpoint is going to be equal to the end point. What's y1? 10 plus, we don't know what y2 is yet, over 2. And then we're going to solve this the same way we did for our x's. What should I do first to solve for y? Multiply both sides by 2. Perfect. Since we're dividing by 2, we want to multiply both sides by 2. So it cancels out with just the denominator. 2 times 4 would be what? 8. So 8 equals 10 plus y2. What would we do next? Subtract 10. So 8 minus 10 is -2. So -2 is our y2. So this would be our other endpoint. Definitely. You can always check your work by taking your 2 endpoints now and using the midpoint formula that way.
Why are you using the midpoint formula by already using the midpoint?
Because we're looking for the other endpoint. So since it gives us the midpoint, we can use the midpoint formula to find our other endpoint. Because in our midpoint formula, we've got 2 endpoints and it's equal to our midpoint. Right? So since we know the midpoint, I could plug that in to help me solve for what's missing, which is the other endpoint.